Good morning, everybody. I am Tony Tagliaferri. I'm Division 10 Traffic Engineer for NCDOT. We've got a great session this morning called Creating a Smart Future. We've all gone through a pretty dumb last year, so we're all ready for something a little smarter here going forward in our future. So I'm not going to talk too much here myself. I'm going to go ahead and get this thing started and start introducing our first speaker. Our first speaker this morning is Mr. John Ringler. And I've got, yep, there's John right there. John is a vice president with Econolite Systems and has led the delivery of some of the largest, most complex and innovative transportation management system projects across North America, Asia, and Europe. A recognized leader in the field, John has a broad background ranging from optimizing traffic flow and the planning, design, and deployment of the supporting network infrastructure, including wireless transmission. With over 35 years experience working with hundreds of public agencies to address and solve real-world problems, John is committed to leverage his skills and background to explore new methods and business models to enhance mobility. And John's presentation this morning is titled Signal Priority Requirements for the Connected Vehicle Future. John, take it away.
Well, thank you, Tony. I appreciate that. I wish I could say that I was getting used to presenting on Zoom, but I'm not. And I find this actually pretty incredibly awkward to do when I can't actually see your faces. So I'm just going to begin to wax nausea. I will trust Tony. If there's any questions or you want to raise your hand during the presentation, if I don't see you, then Tony, perhaps you can interrupt me and we can take questions as we go if you'd like. What I'd like to talk today, though, is about signal priority. We actually started this program actually with the city of Charlotte back in about 2016. I think Tony left around that period of time from the city, and it's actually turned out to be a really cool and interesting opportunity. But to begin, we have to kind of differentiate between transit signal priority and preemption. In the TSP world versus the preemption world, you basically differentiate between giving a bus or a vehicle priority versus an emergency vehicle preemption. Preemption actually destroys the integrity of the coordination, whereas TSP tries to shorten and lengthen phases and maintain the integrity of the coordination mechanism. So we actually came up, no, this is not working. We actually came up with this concept, excuse me, called a signal control prioritization. So we don't really do TSP anymore. We do signal control prioritization, SCP. SCT talks about a priority request generator, priority request servers, and coordination mechanisms. And those are some of the terminologies that SCP uses. It's very similar to the J2735 standard for connected vehicle, which talks about signal request messages and signal status messages. They are different standards, however, but they are both very ETA centric and also talk about vehicle classes. So when we begin to talk about vehicle classes, we don't have to talk about TSP for transit and preemption for emergency vehicles. We can actually mix and morph different vehicle classes, not only transit and emergency vehicles or railroads, but we can also talk about freight vehicles and other road users, pedestrians, bicycles, etc. And they can all fit within these 10 different classes. I believe these are class type. Underneath the class type, there's for each class type, there's a class level, and there's 10 additional class levels within each class type. So you can identify 100 different road users within the NTCIP 1211 signal control prioritization world. So let's talk about route priority. When we talk about route priority, what we're really trying to do here is we're trying to merge a couple of different worlds together. We're trying to merge the world of a traffic signal system knows where all the traffic signals are at, and they understand what the current operations of those traffic signals are at on a second-by-second basis. But where we wanted to kind of begin to move away from this concept of I've got a transmitter in a vehicle and I've got a receiver at the intersection, and within that line of sight, I'm going to try to do something special for that vehicle, whether or not it's a transit vehicle, an emergency vehicle, or any of those other road users that we're talking about. So we wanted to try to provide future state knowledge. We wanted to provide kind of a look ahead of what was going to happen, which means we need the route information. Now, in the connected vehicle world, the J2735 standard and the NTCIP 1211 standard, neither one of them has any concept of what a route is. But we wanted to merge that route information. If I know where that vehicle is going, I know when it's going to turn left, then I can calculate the ETAs and morph that together with the desired phase as well. So in this particular case, we had the traffic signal system, we had the emergency system, and we wanted to also kind of bring in this transit system as well and see if we couldn't bring these three things together into this route priority mechanism. So when we do this, we had a couple of rules that we wanted to follow. One rule is we didn't want to add any new infrastructure. If there was a transmitter or receiver out there, that's great, but we didn't want to actually have to install any new infrastructure. Nothing new in the cabinets other than what might already be there for the ATMS, and nothing new in the vehicles other than what may already be there for the AVL system with the transit or the emergency services. We wanted to satisfy the needs of each stakeholders. Now, when we started this project, we were just looking at emergency vehicles and transit vehicles, and as well as the transportation department, and the needs of each stakeholders were actually fairly easy to identify. The transportation system, Charles Abel with the city of Charlotte, said, you know, I really want to minimize or eliminate the total number of preemption calls, because every time I get a preemption call, my signal drops out of coordination, de-optimizes my performance. The transit system said, I wanted better on-time performance. I want to be more predictable on when I'm going to arrive and satisfy my schedule. And the emergency services wanted enhanced response time. If I can shave a few seconds off an emergency services call, well, that could actually map to safety and lives. And we have, as I already mentioned this, but we want to provide a sense of the entire routes, not just the next look ahead intersection or the next two look ahead intersections, but the 3, 4, 5, or 6 intersections downstream, so that I could make minuscule adjustments to those downstream intersections in order to prepare the intersection for that vehicle's arrival and satisfy that vehicle based upon the vehicle class. So we want to provide that additional future state knowledge. If I've got, if I can anticipate my ETA 6 intersections downstream, even when that intersection may be over the horizon or a couple of turns away, the more future state knowledge I have, the more fine-tuned adjustments I can make to the intersection and maintain the integrity of that coordination. Wanted to adjudicate demand based upon vehicle class. It's pretty simple to imagine. I've got an emergency vehicle and a transit vehicle. If the transit vehicle enters first, I want to be able to provide priority for that emergency vehicle over the transit vehicle, even though the transit vehicle entered the intersection first, because that emergency vehicle is just going to be a wee bit more important than the transit vehicle. But you can also imagine an emergency case where I might have a life-saving equipment, maybe an ambulance or a hook and ladder, or some type of life-saving equipment that needs to get to the scene of the incident, and I've got the supervisor as well. Well, I've also got to get the supervisor to the scene of the incident, but perhaps not ahead of the life-saving equipment. And I only wanted to impact the desired phase. I didn't want to do anything floozy like, if I've got my left turn signal on, then I can turn left at that intersection. I'm going to call that phase 5 or that phase 1. With that route information, I can anticipate where those turns are at, and I only want to impact that desired phase, again, to manage the optimization of the intersection itself. So how does it work? If we looked at the transit use case, the first question the transit vehicle may want to ask the intersection is, when I get there, say 43 seconds from now, will the light be green? And if the traffic signal responds back, and this is unique actually for the traffic signal to respond back, yes, I'm going to be green when you get there, then the appropriate course of action is to do nothing, right? I don't have to actually issue that priority call. I just let the signal do what the signal is going to do, and it's going to be green when the transit vehicle gets there. If the answer is no, then I want to execute that transit priority scheme. I want to shorten or lengthen a phase in order to, the objective now is to minimize the delay at that intersection, not necessarily guarantee a green light, all right? When we move on to the emergency services case, it actually gets a wee bit more interesting, but we start out the same way. The first question is, will I get a green light when I get there? And of course, if the answer is yes, no preemption, no priority, I don't do anything, I just let the intersection be green. If the signal responds back and says, you know what, I don't think I'm going to be green when you get here, but if I shorten a phase or I stretch a phase a little bit, I might be able to guarantee you that green light. then I want to execute that shortening or lengthening of phase and maintaining the integrity of that coordination and let the intersection be green that way. However, that emergency vehicle does deserve a green light when it gets there. And if the traffic center responds back and says, you know what, there is nothing I can do except to drop a phase or eliminate a pedestrian or whatever I've got to do in order to give you a green light and serve you the green light, then I'm going to do that. And then and only then what might I execute a preemption mechanism. All right. So as I mentioned, we've got all these different vehicle classes, and in the connected vehicle world, I can begin to introduce additional road users. Freight movement might be a great user. Platooning of vehicles. If I can actually identify a platoon of vehicles, perhaps then I want to give that platoon of vehicles priority over an opposing phase that may have stretched vehicles, may not be as tightly platooned. I can also do this for bicycles, pedestrians. We're actually doing it for bicycles. I'm trying to remember where in California, but a very bicycle friendly community. And the center to center connection is a bicycle app. So let's go through a DILO or a day in the life of. This is the Honolulu system. And you can see these buses out here. These are our feigned buses. This is the power of PowerPoint and not a live demonstration. But if we set these vehicles in motion, you can actually see the vehicles now begin to move, and they're doing what they're doing. They're going along their routes. They're picking up passengers. They're dropping them off, and they're circulating back through the station and then back out again. But something happens, and in this particular case, what happens is I've got an alert. It's a center to center alert from the transit system. The description is I've got a transit vehicle that's behind schedule. Now, the arbitrary rule that we might set up here is if a transit vehicle is 5 minutes or more behind schedule, then I actually want to give them priority. But if they're not 5 minutes or more behind schedule, then I don't want to give them priority. We actually identify where the vehicle is at. And then if we wanted to zoom to that vehicle, what we're actually going to be able to see on the ATMS map is we're going to see two things. One, the transit vehicle that's behind schedule, we're going to highlight in some fashion. And we're also going to paint the route so that the transportation operator can begin to see which intersection is going to be impacted to get this vehicle back on schedule. Now, he's actually highlighted because he's 8 minutes or more behind schedule. And I told you that if he's 5 minutes or more behind schedule, then I'm going to highlight him. I'm going to give him special treatment. This guy's not highlighted because he's 2 minutes ahead of schedule. This guy's not highlighted because he's only 2 minutes behind schedule. And this guy never happens. He's actually right on time. Now, I'm a transportation guy, not a transit guy, so I probably shouldn't have said that. But. So as this vehicle down here begins to go through the intersections, we're actually going to begin to paint the intersections that are going to be impacted as well. So these are the intersections downstream along this vehicle's route. And you can see that the intersections are over the horizon or around a curve. I can't see them, but I can anticipate and calculate the estimated time of arrival of that transit vehicle. So again, as we set this fella in motion, what you're going to see is basically it's not a check-in or a checkout per se, but it functions very similar to a check-in and checkout. The check-in is I've got an estimated time of arrival, and that's what I actually want to serve. But once that vehicle does pass, we want to release the intersection from any further impact from that vehicle. So you can see these two intersections here now have turned off, and as we continue to set this guy in motion, you see he's 4 minutes behind schedule. You say, okay, well, he's still got priority. He's still got the purple halo around him as well as these additional intersections, but he's only 4 minutes behind schedule. And you told me that if he's 5 minutes or more behind schedule, then and only then do we want to give him priority. Well, the question is one of the many edge cases that we actually ran across. And in this particular edge case, we wanted to consider the fact that we wanted to get a vehicle enough on time so that we weren't ping-ponging him back and forth. So let's get him on time. Let's get him to a point where he's not going to be requesting priority again. He can just run through the intersections in an ordinary fashion. So as he continues to pass through these intersections, we're going to turn these guys off as he passes through. And you can see here that he's still got a purple halo, but he's 2 minutes behind schedule. He just lost that purple halo. So at this point in time, we can retire any future priority calls, and we can retire the route. The transportation operator doesn't need to know where that transit vehicle is at anymore, or that he's requesting priority because he's not requesting priority. So that's the transit case. In the emergency services case, and this is in Johns Creek, just right around the corner from my house, a bit more complex, you might say, because now we're going to have a center-to-center fire incident. My house is on fire because I'm not creative enough to think of, the other type of emergencies that a emergency services system may run, but a house is on fire. And the house is located at this 2457 Laurel Springs Road. Of course, we're picking this up from the computer-aided dispatch system, the 911 system. And the responding vehicles are 3 of them in this case. So let's see where those responding vehicles are at. All right, there's our responding vehicles. We got a guy here, we got a fellow here, we got a fellow here, and we got the house on fire up here at Laurel Springs. All right. I believe we can tab through this again. This guy is vehicle number 615. He's a supervisor vehicle, and I'm going to give him a class 5. Now that's up to the users. It can be negotiated between transportation folks and the fire folks. But this guy, he's a supervisor, so he gets a class 5. This guy is a hook and ladder truck. He's a class 4. And this guy's life-saving equipment, he's an ambulance. He's a class 3. So I can manage these different classes of vehicles now as they pass through these intersections, all on the way to this fire. So the first thing I'm going to do is I'm going to calculate my ETAs. The center interface is actually really simple. I need the vehicle position, the speed, heading. I need his routes that he's on, and I need his vehicle class. And with that information, I'm going to calculate his ETA at each intersection. So this guy has an ETA at this intersection 8 seconds from now. He's going to be requesting phase 4. 615 has an ETA at this intersection of 43 seconds. He's going to request phase 4 again because he's turning right. But now he's going northbound, and that's a phase 2. And his ETA to this intersection from this point in time is at 58 seconds. Okay. Now, all these other vehicles are getting ETAs as well. So we're kind of adding some complications to this. And I apologize for the font size here not fitting within my bubbles. But each one of these additional vehicles also gets an ETA, and they're all going to be competing for this one intersection here as upon arrival. So as I set these guys in motion, I recalculate the ETAs. In fact, I'm going to recalculate the ETAs every time I get a positional update. In the fire case, that's about every 3 seconds. I'm going to continue to calculate those ETAs, and we're all rushing to get these guys to the scene of the incident. So this hook and ladder truck now gets to this intersection first. He's right at the intersection. And I continue through the system. Now you see this guy's still got a purple halo because the hook and ladder, or excuse me, the ambulance hasn't actually gotten through this intersection yet. Continue to calculate the ETAs. No longer do I need to calculate an ETA for this guy because there's no more signals along the way. Continue to calculate the ETAs, and now I've only got one left. This guy is beyond the last intersection. My ambulance is 6 seconds away, requesting phase 2 at this intersection. Continue along the routes, and when he passes that point, I can actually retire the routes, retire the vehicles, and make them disappear from the map again, because I've done my job in order to serve those vehicles using the infrastructure that's already exists. So do a couple of quick case studies. We implemented the system in Miami-Dade County on US 1. When we started the project, the average travel time on US 1 from Miami down to the south was actually a fairly long route, was 64 minutes. And we're able to reduce that route by from 64 minutes down to 49 minutes. So a fairly remarkable improvement in reducing the total amount of travel time for those buses. The case study in Charlotte is actually really interesting. Around about 2017, we were just thinking about finishing up the system. And in 2017, we had the average response time for an emergency vehicle was 3 minutes and 34 seconds, which is actually a pretty extraordinary response time. When we started this project, and I've had this conversation with Tony, and he would agree. I had no idea that we would be able to save using these mechanisms a substantial amount of response time when the average response time was already only 3.5 minutes. In 2018, we started getting some of our initial results in. We actually had some real struggles, and some of you are on the call, I'm sure, have been through this with us, but real struggles with our firmware. But we were able to see actually a 2-second improvement in the average response time for these emergency vehicles. And I at that point in time, I thought, hallelujah, that's phenomenal. That's a great result. 2 seconds is, again, seconds are lives. But in 2019 was our first complete year of operations, and we're able to further reduce the average response time by another 20 seconds. Absolutely a phenomenal result for the city of Charlotte, and I'm looking forward to getting the 2020 results as well. So Tony, I think with that, I think I'm pretty much wrapped up. We've got some dashboarding here, and we're feeding these into our SPMs. That's about where we're at with this this presentation. I hope I didn't take up too much time.
No, I appreciate it. Thanks, John. We actually we just got one question in the chat, literally just now. And when you do ask questions, I guess I failed in my moderator duties. Please try to use the Q&A function, just because it's easier to pull everything out of there in case we get some conversation going in the chat. But John, we do have one question. Since we have a couple minutes, I'll go ahead and give it to you here now. How do you force the turn off of the signal priority once past the signal? We have this for our fire service, and sometimes they forget to turn off the preemption.
Oh, the operators don't actually have to worry about turning off the preemption. What we're actually doing is picking up the position of the vehicle. We know the position of the intersection. When we actually realize that that vehicle is passing the intersection, we turn off preemption. So it's the position of the vehicle that turns off the preemption, not any physical switch in the vehicle.
Good deal. Thanks, John. I appreciate it. And thank you again for your presentation. That's all the questions we have for that one. If you have any other questions for John, feel free to add them to the Q&A, and then we can have some time at the end of this. We'll circle back with any questions that we didn't catch, and we'll ask at the end. Our next presenters are Ron Boenau and Samuel Trotman. And Ron, well, here, let me give you the title of their presentation first, because I didn't do that with John last time. Virtual failure here by me. But their presentation is Smart Communities, a Framework to Success. And I've got Ron's bio right here. Ron Boenau, professional engineer, is an international transportation research advisor with over 40 years experience in transportation research, development, demonstration, deployment, database evaluations, and related training. Most of his experience has been with the research offices of Federal Highway Administration, Federal Transit Administration, and Florida DOT, bringing research of advanced systems and technologies along with innovative user services to deployment. Within US DOT, he was the ITS Transit Division Chief, working with state and local DOTs to conduct research projects to advance the state of the art, and was the International Program Manager, developing and implementing international collaborative agreements on advanced public transportation systems and technologies. After his retirement from US DOT, he continues to contribute to the advancement of transportation systems and technologies through technical committees of ITE, ASCE, ITS America, SAE, and TRB, that's a lot of acronyms, and is an advisor to the Transportation Institute at the University of Florida. Ron has an AA in Science and an AA in Arts from the State College of Florida, a BCE in Transportation from the University of Florida, and a Master's in Civil Engineering and Transportation from the University of Maryland, in addition to completed graduate programs of transportation from Northwestern University and the University of Mississippi. And let me also provide Samuel's bio, because they're going to be teaming up on this presentation. Samuel Trotman, professional engineer, CISSP RCDD, is president and director of integrated technology at SpectrumHaven LLC, and currently serves as the ITE Smart Communities Committee Chair. He is also a member of the Board of Directors for Infrastructure for the People, a nonprofit organization whose goal is to transform communities through training and hiring the long-term unemployed. Samuel has over 16 years of experience implementing advanced technology system solutions, specializing in communication architecture and infrastructure design, advanced technology systems integration, and public safety initiatives. He has designed several large-scale fiber optic and wireless communications networks utilized to support the integration of various Internet of Things sensors, and architected security technology solutions across various transportation-focused verticals. His expertise in the implementation of intelligent mobility projects, telecommunication infrastructure, network architecture design, cybersecurity resiliency, and big data Internet of Things aggregation is paired with the understanding that technology is a tool to be used to improve the quality of life of those it touches within communities. Samuel has a Bachelor's of Science in Civil Engineering from the University of Florida, a Master of Engineering in Civil Engineering, Transportation Focus from the University of Florida, and a Master of Science in Computer Science from the University of Florida. So I will bring Ron's slides up here. And then Ron, I'll let you give me the command when you're ready to have me move the slides.
Sure, Tony, we can begin with the title slide.
All right, you should be seeing my screen here in just a second.
Okay, good. You know, one of the most popular topics at conferences, forums, and seminars during the past few years has been smart transportation, smart communities, smart cities. Often, however, these references are mistakenly represented by smart applications. That is, technology solutions specifically designed to independently solve an identified problem or technology. A truly smart communities initiative, on the other hand, would engage a suite of technologies selected to implement a framework that would produce a more comprehensive and robust solution to the issues needing to be addressed, and would involve a variety of stakeholders that all would be addressed in that area. And we would involve also multiple sectors of the economy producing benefits to a much wider segment of the community. A smart application is primarily a one-dimensional with a focus on technology rather than on the framework of the system itself. With the rapid pace of technology advancements and smart technology today, we can quickly become, or it can quickly become obsolete and dumb tomorrow. The presentation that we are going to be doing now with Samuel and I will be looking at different aspects of it so that your project would not become dumb in the sense of being obsolete. Go ahead, next slide. And what we'll be doing in this presentation, we'll look at a couple of brief illustrations that help to show how easy it is to develop a mistaken understanding of what constitutes a smart system. We will then cite some key components of a smart community to include the process, the stakeholders, the roadmaps, the architecture, communities, and we'll conclude with identified pillars of success that will maintain a smart community. Next slide. What I thought I'd do is go ahead and do a nice little simple illustration that would be easy for us to understand. And we'll call our little model here Susie, even though that's not her real name. Susie is a very active 4-year-old who has demonstrated her ability to handle a lot of various activities, and she can understand and solve complicated problems to the surprise of many people, and is considered to be a very smart child. With that being said, let's go ahead and go to the next slide. And many of you have your own children or your grandchildren, other relatives, but you find that she or he have very much been involved and has been considered to be smart. So if she's smart at 4 years old, what's going to happen, let's say a few years from now? Let's go to the next slide and project what happens, let's say when she's 10 years old or when your boy is 10 years old. With that, they've already demonstrated a number of activities of working together with other children, but still not collaborating together with that many people. Go ahead, we'll go to the next slide. What about 20 years from now? Now, remember, we're using this as an illustration because we're going to move quickly into ITS activities. At 20 years, it's kind of interesting because by this time, the person is in college. They're actively involved in the ITE chapter. They're an officer there, and they've been demonstrating their capabilities once again. So here again, we can call this person a very smart individual. So now we have another process that's going to be taking place where smart is considered as a key component of this person. Next slide. Finally, we'll go ahead and just look at 30 years from now, when the person is already well involved in the industry. Once again, they've been considered to be very smart. They're very active in their ITE program. Of course, they started off as a student, but once again, we've got several different definitions of what is smart. And we'll be moving into this next area then too. So other than a personal illustration here, let's look at the ITS activities now too. Next slide. Smart communities. What we're looking at here is just to be able to identify exactly one of the things that I was mentioning earlier, that what is a smart community? We'll look again at this process of how we look at smart things. Next slide. The the domestic program here in the United States began really in the late 80s, but then the first legislation that came up was the Intermodal Surface Transportation Efficiency Act of 1991. This ICE legislation had a number of independent research projects that we began to put together, and within the first 4 years, we sort of like moved from the childhood stage into the older child stage. ICE was considered to be the visionary legislation because it provided for intermodalism, intergovernmental partnerships, addressed mass transit, and it was an interconnected transportation system of the future, the way the presenters gave to it. What is interesting about this, though, is that back in those days, in the early days of ITS, we still considered the things as smart traveler, smart vehicle, smart intermodal systems were already in use. But of course, as we look at it today, these terms have changed significantly. Next slide. As we moved on from the childhood stage in ITS into the pretty much the young adult stage, T21 was the next legislation that sort of drove the country into the next status, from childhood status to that of young adult status. And it was significant because at this time it incorporated an architecture and a standards program, which FHWA and FTA made into a requirement for federal ITS funding. Now, this initiative began to be focused more upon people and quality of life rather than upon concrete, asphalt, and steel related issues. So this shows a maturing of the process itself of moving into what is smart and what is not so smart. Next slide. Another major piece of legislation, and you won't be able to see this, but that's okay. It's safety loo legislation. Safety loo built upon the ITS Smart Transportation Foundation that was established as the initiative matured, and it developed and spread throughout the country. Focus was at this time upon more continued conformance to national and regional architecture. And then it also had a systems engineering approach and process that was going along. Next slide. As we move along quickly, MAP 21 and the FAST Act, these all help to assure the adulthood now with the ITS initiative. And SMART was still considered to be even smarter than what it was before. Next slide. And then with MAP 21, this really brought into maturity the whole idea, but it shows how changes took place over the years from when we first considered what was smart and what was not smart into what we are now of considering what is smart, what is not smart. So the definition actually changes. Just as a child is smart in the earlier days, smart in later days, still also the ITS community considers itself to be smart. So what is smart in the past years may not necessarily be smart today. So how can we as project people, planners, engineers, designers, make sure that our system continues to be smart and not dumb? Next slide. So what we'll be looking at here, and Samuel will go ahead and move into a little bit further development of this, is that we need to be aware of what is smart and what is not smart. So what we'll be looking at now is how we can maintain our projects, our activities as being smart and not dumb. Samuel, go ahead. We'll let you go ahead and take care of the rest of this.
Thank you very much, Ron. Give me 1 second. Good morning, everyone. Hope you enjoyed the conference thus far, and thank you for choosing to join our session this morning. My name is Samuel Trotman, as my co-presenter Ron stated earlier. And as Tony stated, I am currently serve as the chair of the IT Smart Communities Committee. So smart communities are of interest to you on any level. I would like to take this opportunity to invite you to join our committee. We have a meeting scheduled later this month. So if you were interested in that, my contact information will be available at the end of the presentation. That's into my plug. We have a lot to discuss in a little time, so let's get started. I wanted to start off by presenting the various components of our smart community. Before I do that, I wanted to differentiate between the use of the term smart community and the term smart city. We'll be using smart communities throughout the presentation because the term smart community is more inclusive, as is representative of both rural and urban areas, encompasses municipalities of various sizes and types, and provides a broader perspective that crosses city boundaries to look at initiatives on regional, state, and even larger scales. On the slide, you'll see I've listed various components of a smart community. I'll be referring to these as pillars, as Ron says. You could view them as an a la carte menu. It would be very ambitious if you were to try to undertake all these at one time, so we do not recommend that. Instead, we recommend to prioritize those that are most important to your community and look for opportunities to integrate the others along the way, focusing on low-hanging fruit. Sorry about that. As you can see by how much the slide is taken up by the word process, the process is pretty important. The key to implementing a smart city community, a smart community, is developing a process. Okay, so basically we're done. Well, we've broken it down into 4 steps: identifying your internal champions, 2, your stakeholders, 3, identifying your key issues, the community concerns, 4, your implementation roadmap. Each of these steps we'll discuss later on in more detail. But as you can see, being smart can sometimes be pretty simple. As long as you have a path moving forward that you defined, it's pretty much creating your own instructions manual. So the question you may be asking, who are our internal champions? Some potential examples are mayors, city managers, directors of IT, smart city directors is pretty obvious, directors of innovation. This is a relatively new term and role for most. I like it because it tends to be created specifically for smart community initiatives. In my conversation with various communities, I spoke with several people and it seemed each identify their champions as someone different. Sometimes it was one person that simply wore multiple hats: the director of engineering, who was also a smart city director, and point person for all topics involving smart communities. It's important to note that champions do not need to be the highest ranking people in your community, but they need to be liaisons to decision makers, especially if they are not solely empowered with those permissions themselves. Their key role is to establish buy-in to the overall vision. Next, we come to stakeholders. Based on this slide, it would seem the more the merrier. That may be our end goal, but I wouldn't recommend that at first. Initially, you want to limit the number. Too many cooks in the kitchen. We all know that expression. But the goal is to create an inclusive community. That starts by having a core group to discuss the bigger pictures: who, what, when, and why, and also where. Why are we doing this? Who do we need? Our internal champions. Not necessarily getting to the specifics of what are we doing, but more what do we want to accomplish. This goes back to the why. Then the when will most likely come later, but rough ideas need to be discussed to create momentum to help provide others a sense of urgency. The eventual where I mentioned before is evaluating the potential scale of the initiative: local, regional, and further. It's probably best to start small, but doesn't mean that your initiative needs to stay small, especially if they show promise. I say if they show promise because everything you do is not guaranteed to be a success, but that doesn't make it dumb. Not adapting does, though. So I expect a lot of us in the audience are engineers. So this concept should be not unfamiliar to most of you. Building a smart communities roadmap. It's illustrated by the graphic. It may not always be a straightforward path, but you may encounter some turns and some obstacles around the way. But this is where the fun and innovation really comes in. So a roadmap has 3 steps. 1, prioritize, define key issues. We'll get into that shortly. 2, develop an architecture. Ron spoke about it, and I'll speak about it more specifically on a smart communities framework. And 3, having an implementation strategy. This is very important. Not that the other 2 aren't as important, but this you'll see is a key player in this. So whenever I try to list out steps, I don't normally like saying one is more important than the rest, although I kind of just did that a little while ago. But if I'm going to single out one, it's community engagement. Smart communities is about improving the quality of life for all those in the community, residents, visitors, or those passing through. Community engagement, it helps prioritize pillars, provides insight into what are the community touch points, guides how best to improve the quality of life for residents of the community, and helps dictate initiatives. Define pillars. Like I said before, I don't recommend you bite off more than you can chew. Back that whole a la carte idea. Prioritize pillars on community engagement and stakeholder feedback. Plan strategies to slowly integrate other pillars. These may be something that you involve in your midterm or your long-term objectives. You don't want to lose momentum, so identify impactful quick wins under short-term goals. Try to target, once again, low-hanging fruit in your short-term goals to accomplish this. Make sure you define objectives for initiatives. Don't simply list them. Articulate why you've chosen them and why they're important to the community. And lastly, flexible and adaptable. One event sums this all up. COVID-19, you have to have a plan to adapt to conditions as they arise. So once again, we're talking about community engagement. As I said, it was important. To improve the quality of life for those in community, you need to have an accurate pulse on the community. To accomplish this, we need to poll the community to understand the actual needs versus the perceived needs. So often I've been involved in conversations where the perceived needs and what seemed to be important were actually symptoms of a much longer systemic issue. So what do we do next? As you can see, we poll again. We're trying to reach the highest percentage of community as possible. We want to reach all segments of the community to have a truly representative feedback. So our hope is polling multiple times and we are able to reach larger numbers of that different and larger groups of different people within the community are able to attend. So guess what you do after that? You poll again, but we wanted to kind of mix it up, have different formats, take into account people's schedules, whether it's work, school, other things, provide online surveys, Zoom meetings such as the one we're doing now. Be as creative as possible in order for you to accomplish the goal of bringing all of these people from the community into the conversation. And then finally, poll again, because things change. Once again, perfect example is COVID-19. One community that I spoke to about smart community initiatives in their specific community actually postponed their kickoff date for their initiatives so they could poll the community again to see how COVID-19 played an impact on what it is they had planned. And change presenters. The agencies hosting or in attendance sometimes can make the difference. It may generate a different audience and message from having the mayor present as opposed to having the city engineer or a smart community director. In the abstract, as Ron kind of alluded to earlier, we talked about smart applications and how they may contribute towards making your smart community initiatives done. I want to clarify that those were siloed applications. So it's not to say avoid all smart applications, especially when they begin to be integrated into the architecture and the initiatives that you have going on. On the slide, you'll see there are examples of initiatives under various pillars, as I mentioned before. But one example I want to point out is under smart energy, the LED lights. In the past, this has usually been the first introduction to the realm of smart cities for most communities. This one specific community chose to define this initiative in part as a revenue generating tool via the project savings they expected. The savings were tracked and quantified and then earmarked to be reinvested into implementing additional initiatives. This was part of their roadmap that was documented and defined. Key point, documented and defined. So there's nothing really dumb about coming up with initiatives that can help fund growing your program, as this community did. And it couldn't be a presentation by an engineer without the systems engineering feed diagram included. So what I want to touch on is one, the regional architecture. This is an idea of moving from a local perspective with the smart community initiatives to a more regional focus. The idea of incorporating neighboring communities. I believe this is what makes a smart community truly brilliant. Also, the high level design that is going to be needed to, one, prioritize your initiatives, develop your timelines, the near term, the midterm, and the long term, and will be utilized for securing funding down the road. As a part of this, we can look at and let's focus on the O&M costs, but equally important is the effect it will have on staff. Factor in the costs needed to be invested in educating your team. The goal is to bring them up to speed, have a valued asset, not put them out to work. Finally, changes and updates. This is not a set it and forget it type of initiative. It needs to grow, change, and adapt as the community does. So having an understanding of how this can be done is essential. And if it can't be done, you really need to take a step back and see if this is really the best initiative for your community. Your smart communities architecture needs to be a living document that is routinely reviewed and updated. Like I said before, this isn't a set it and forget it type of tool. So it definitely is not a tool to be stored on a shelf. It is the driver for all of your smart community initiatives. Keyword is as opposed to should be. Going back to the ITS architecture, I like to use Minnesota DOT as an example. With MnDOT, any ITS project that was implemented first had to be evaluated against their regional architecture. If it didn't fit into their existing architecture, one, that had to be noted. But more importantly, what needed to be revised in the architecture to update it accordingly was documented and evaluated. A similar approach is highly recommended for smart communities architectures moving forward. Wants versus need. First things first, focus on your defined goals. That's the whole point of having the architecture and the roadmap. This will keep you on the right path and help you from steering off course, which is crucial to achieving your overall vision. Smart applications. Use caution when dealing with the allure of shiny new widgets. New technology comes with a suite of cool functionality. And that's basically what makes us want to buy it. But the majority of users don't use those features, not because they don't understand them, because there never was a plan for how to do so, so they forget about them. This prevents innovation because if you don't understand what you have, it makes it harder to envision what can be. Once again, going back to having a plan. And that plan helps others create those thinking out of the box type solutions. You want to utilize open architect solutions. So you're avoiding proprietary technology that creates information in silos. The vendor technology is a tool, it's not the answer. You should be able to switch it out as you would switch out an old or stained pants or shirt. So if I were to say that I was willing to give you a free tuxedo or a designer dress, you'd be like, oh, that's great, thanks. But if I then were to follow up and told you that you have to wear that same outfit every day for the next month, that wouldn't be too helpful if you're doing yard work. You want the freedom to utilize and create APIs for software interfaces into your community-defined solutions, not vendor-defined solutions. You definitely need accessibility to raw data. This is not a want, this is a need. Even if you don't know why, someone talented on your team eventually will figure out what you can use it for. Once you have the data, what do you do with it? The answer is to transform it into useful information that is defined in your architecture. You can see everything that we go back to is always being defined in this architecture that we're talking about. So you make sure one thing is that you define format standards within this architecture. Then the data could be used for simulation modeling that could build use cases justifying capital improvements. You could use it to create virtual environments to simulate real world situations. This can result in cost savings before even implementing a pilot study. And if you're lucky, like some communities, you might have a test bed. Funding. You have to plan for success to ensure you have the resources to see it to the end. In your short term, less than 2 years, this is a sweet spot for pilot projects. What happens if you if you haven't planned for amazing success in the pilot project, but you want to roll this out into one of your midterm goals? So I've heard of the salve stories and the heartbreak stories about this. And why do I call them heartbreak stories? Because the initiative showed promise. It had the ability to be integrated into other initiatives, but lost momentum when it didn't get out of the pilot stage and eventually lost support. Out of sight, out of mind, or even worse yet, perceived to be a failure by those who aren't directly involved in the project because they didn't get to see it proceed further. I think that's about my time, but before I go, I would like to say thank you to some of the communities that provided value insight into the presentation: the City of Atlanta, City of Chattanooga, City of Coral Gables, and City of Orlando. And if you would like to reach out and contact us, here is our contact information.
Awesome. Thank you, Samuel and Ron. To this point, we don't have any questions about this one in the chat or the Q&A yet. So we will I'll keep an eye on those, and then we can add anything on at the end here. We did have one question for John that I asked John and got an answer, so I'll be able to answer that one at the end here also. But for now, our next presenter is Mike Flood from WSP, and his presentation is titled Risk Analysis to Guide Better Resilience Investments in Transportation. Mike Flood is the National Resiliency Lead for WSP and has over 25 years of experience in the consulting industry. Mr. Flood has led most of the firm's national projects focused on determining the risks of extreme weather and climate change on infrastructure and communities, and the development of strategies for addressing those risks. The focus of Mike's recent work has been the development of methods, tools, and strategies to help agencies and stakeholders make effective capital investment decisions and adaptation to climate change and extreme weather risks through development of data-driven decision-making tools and prioritization processes. This has involved recent work developing benefit cost assessments of resiliency projects nationwide, work defining risks and responses to a variety of climate concerns, and the conduct of training seminars on resiliency strategies focused on helping agencies make effective decisions. Mike holds an undergraduate degree in urban planning from the University of Maryland and a master's degree in environmental planning from the University of Virginia. So without further ado, Mike, looks like you got your presentation queued up, ready to go. So take it away.
Great, thank you. Good morning, everyone, and thanks for your time. And hopefully I could be as smart as the last presentation or as pertinent as the previous presentation. But you know, this is kind of a big topic in federal legislation right now, and filtered down through many of the states, particularly in the Southeast. So I think it's just good context for you to have in mind. And certainly there's a role for everyone in transportation, which I'll try and highlight here in a little bit, but certainly role for participants in the ITE frameworks as well. So, so with that in mind, I'll just kind of get started here. So, you know, this question of risk and resilience, you know, the transportation system has been almost impacted, you know, regularly, almost monthly. You get another story about a event that's impacted the network or the system or the community. And you know, there's a few things that are starting to become evident, one of which is you know, the idea of cost effectiveness in planning and design makes sense to a certain level, but then once you start to lose your transportation assets, you really start to feel how that loss of access and asset and you know, the contributions to the economy really have a multiplying effect throughout the region. So you know, resilience is such a big topic because people recognize we do need to think differently about it. We need to think differently about the value of transportation. We need to think differently about how to approach it and how to make more effective decisions, which is really the kind of the intent of this presentation. So, you know, with regard to impacts. This slide graphic basically shows the the CPI adjusted $1 billion disasters that have occurred over the past 40 years, and you can see kind of the highest are all fairly recent activities. So there is some indication that such events are increasing over time, and what's the cumulative cost to communities and to transportation users and to the economy from such impacts is something to think about. So the question is, okay, well, let's just respond. Let's just start to move forward. And so the story about how to best move forward gets to be a little more complicated potentially than it should be, or than it's beneficial to effective decision making. And partly, I wanted to just kind of walk through this exercise to tell you that kind of a tale of two bridges, right? So we have two facilities, and we're kind of considering them from a resilience perspective. So the first one is basically an indicator approach, and if you kind of Google transportation resilience, you're going to get mostly indicator approach feedback, and this is kind of a theoretical approach. So if I'm a transportation agency or I'm an asset owner, I want to think about the effect on my assets, and the dominant approach is this indicator approach. So we take what we have is available data around an asset. We do a assessment of criticality, which many of you have probably talked through. We talk about exposure indicators, which are presence in a floodplain, or other mechanisms that you can get at that asset. You can talk about sensitivity, which are often asset management data points, and then you can weave in adaptive capacity indicators and basically walk through a mathematical process of creating a score for each asset. And this is, as I said, this is the way that a lot of the work that's been done over the past 10 years to try and get to the resilience question is about. So there's a way to kind of walk through this. And as you can see, for those of you, this is kind of indicative of many of the efforts, but it also kind of flows through even some of the approaches to community resilience, where you kind of develop these metrics, you scale them, you weight them, and you score them. And the biggest challenge with them is their complete disconnect from the normal description of math, which is describing a process through mathematical means. And this is just basically a way to score. And the idea is that the score at the bottom would be comparable across assets. That's just a kind of a way that it's most often done. So the second one is basically, if we start to think a little bit more about resilience and cause and effect, right? So for this asset, for this bridge, we want to start thinking about, well, how is it going to be impacted? So, we can go through the assessment. We can say, well, if there is a 25-year storm event, we can anticipate that there's going to be a bridge washout or damage. It's the primary access point into a community. It's going to be, we can anticipate it being about $15 million to fix. It's going to take about 2 months to fix it. So the access along this roadway is going to be impacted during that period. And also during that period, we anticipate a lengthy detour for this is a community with few access points, and there's going to be a very long detour to get around, or to find a way in and out that doesn't exist. And you can see that this is kind of a whole different perspective. This is something that tends to create a more compelling narrative for things. So that for this bridge, we've kind of assembled information. And the trick here is that those were actually two photo perspectives of the same bridge. And you can see how kind of the way you think about resilience and the way you talk about resilience and the way you present information about resilience is kind of clearer in that second one, which we call kind of the risk-based perspective. And that actually presents a much stronger narrative for more effective decision making, but it does require the data. So like I said, if you kind of do a research effort around resilience for transportation systems or communities, you'll see, I just used some very rough numbers here, but you'll see that, there's hundreds or thousands of ones using an indicator approach, and there's very, very few on the risk-based side. So the first thing we need to do to become more resilient as a transportation community, or as a as a profession, is to recognize the effectiveness of these and really trying to make a hard transition into something that's a little bit more compelling from the side of the way we normally do business. So pretty simple to do, right? So basically all we need to do is change the practice of transportation, or find ways to integrate risk and resilience into transportation practice in a way that makes the most sense. But the challenge is, particularly as it relates to future conditions or climate change, is that engineering as a practice, as a scientific practice, is decisions are made today based on observed conditions, past conditions, right? That's the way that science works. You do your analysis, you analyze past rainfall, you analyze past sea levels, mean high water, temperatures, and then designs are made. We design pavement based on past temperatures. We design water features based on past precipitation totals. We do a lot of work on things like mean high water, and so then we therefore need to make this transition. We need to make a transition from basically the past, which is kind of living in this rearview mirror here, to kind of looking forward. And there's looking forward is obviously has more uncertainty, because it's hard to define that change in a way that's different than observed patterns. So that's kind of the first element of change that needs to happen, is we need to start to be looking forward out over the life cycle of the asset, or the life cycle of the system, and understand it at a better level of detail. So another change that we need to do is we need to be thinking a little bit more holistically about design standards and the factors that kind of go into this. And you'll hear this a lot through the language that comes out of the administration, or even the kind of the research around resilience, is that there has to be a different way of thinking about things. So right now we have data, and we apply it as a design standard, and our kind of risk tolerance kind of is the same for many of the assets. We don't say we're going to design thing with a high asset value to much greater level of detail. And the reality is that there are other things potentially that we should be thinking about or considering. So we have to start to think about event-related damage. We should be thinking more about those repair and outage periods and their importance of the transportation system. We should be thinking about social and economic and environmental costs, and effect on low to moderate income community members, and what the transportation system means to them. We need to be thinking about climate change and how those stressor conditions are going to be potentially changing. We need to think about recurrence uncertainties. The way we utilize things like FEMA data, and the uncertainties that are inherent in those but aren't necessarily applied. And then we need to think more holistically about the full assessment of potential future conditions. So that's kind of the theoretical transition that needs to occur. And we say that's it kind of jokingly, because that's obviously a pretty significant set of concerns that need to be reflected in more effective decision making. So there are some efforts underway that might be good reference if you're interested in this topic for moving towards resilience. Federal Highway Administration has been, through previous administrations, has engaged on a few of these efforts. There was a project that they completed, that bullet there, the Transportation Engineering Approaches to Climate Resilience, which was completed about 4.5 years ago, which has a bunch of examples embedded in it about how to make better and more effective decisions. And this flow chart at the right is not something you need to understand in any great detail, but it is basically a process that can be followed for more effective decisions. And one of the things that affects people like ITE are the way they talk about getting to risks. And the way they get to risks is basically, kind of understanding that there are uncertainties inherent in the future, that there could be kind of low to medium or high futures. So we need to find a way to make better and more effective decisions around that. And then the second part, which is basically we need to assess the consequences of those impacts. And we need to basically find ways to incorporate the cost to system users of loss of access, of detours, or cost of, or safety loss, and take that value and weave it back into the ultimate decision-making framework, and incorporate basically consequences in a way that isn't traditionally done in engineering design currently, or planning, or effective or decision-making. And then the point is that at the end of this, if you kind of think about the uncertainties and the scenarios, and you're able to quantify the consequences, then you're able to say to you or your stakeholders, we've kind of done this robust assessment. We're comfortable that project approach 2 is the most cost effective based on that analysis. So there's kind of ways to work through that in a way, and create a narrative and present information in a way that's very compelling based on traditional transportation planning and design processes, which is obviously an important role for those of you on this webinar right now. So we're going to go through just a few other examples. California has been kind of leading a lot of these efforts over the last 4 years. One of the things that they've done is they recognize that there needs to be better ways to communicate this information, and they invested pretty heavily in kind of creating a story around resilience that doesn't require a 2 degrees in transportation engineering and computer science, say from the University of Florida, to understand. They recognize that there are political stakeholders, there are stakeholders in the community that you need to find a way to communicate with. So they've done quite a bit of work on creating a better and more effective narrative for the non-practitioner. That's pretty good examples. And then they have a few of their MPOs out there are moving forward in kind of looking towards this quantification of risk. And one of the things to note here, this is just kind of some examples from the work that's being done out there. You can see that on the left top of this part, they're starting to look at how future conditions might change from precipitation today and precipitation into the future. And then on the right side, you can see that there are at the top part of this kind of this bottom graphic here, you can see that there's a cost to the system in terms of travel time and delay that result from a asset closure that could be identified and quantified through forecasting exercises. There's, that flows into things like greenhouse gas emissions or increases in commute time or commute costs that can all be reflected back. And then basically what that does is the top right here, it enables you to kind of build a life cycle cost estimating framework to enable, like I said, the more robust and effective decision-making frameworks that are identified. So that's like at the project level. And then, transitioning from that indicator framework to a risk-based framework, Massachusetts DOT is actually investing pretty significantly in the definition of the physical understanding of risk to their system. So they are looking at the climate science, they're looking at sea level rise, the changing patterns for storms in the Atlantic, to look at how sea level rise or future storm surge might affect their system. And then they're also doing work to define future precipitation change through science, and then weaving that into an understanding of how floodplains might potentially change, and how those floodplains and the probability of different rainfall patterns might actually physically impact their system. Like, how is it going to affect erosion or scour or or effects on bridge assets. So they're going through an entire kind of data development phase that's kind of highlighted in this slide, which, you know, to look at the range of future precipitation effects, look at the assets, you can see kind of the effects that they're considering, and then starting to look to develop estimates for cost and time of repair, and then weave in the time delay impacts for the transportation users, and then basically summarize that in a no action cost. Basically, what's the risk cost to Massachusetts DOT facilities from inaction, you know, or from the kind of the base case, looking out to the future, what type of cost could be anticipated for Massachusetts DOT and its users looking forward, and then kind of be able to utilize that information to make the case for better or more effective investments. So another point is the National Academy of Sciences, through the NCHRP program, has developed a report that's due to be published this week or next week. It's NCHRP 970, and the title of it is Mainstream System Resilience Concepts in the Transportation Agencies. And this kind of the step framework over the right is the way that the document is organized, which is basically, you know, if I want to create a more resilient agency or private sector company or community or public sector or private, you know, private sector, you know, I'm a person, you know, I'm a manufacturer. How do I start to make better, more effective decisions? So this thing is set up that each of these steps are identified and kind of guide you through more effective decisions across all of this. You can see how it's kind of set up to do that work. And the document itself is basically set up as a capability maturity model, where you're able to walk through, answer a few questions, kind of rate yourself based on your maturity for different factors, and then be given an output that says, here's some strategies that can be put in place to become more resilient. And you know, a lot of this, as you can see, it's intended to be entirely risk-based as much as possible, to kind of push you to think about things in a different way and make better and more effective decisions. So moving forward, there are some kind of some research and development needs, and we put this graphic in there. I put this graphic in there. This is basically identifying that as conditions change, there are costs associated with that. So as sea levels rise and start to impact users or pavement quality or overtopping or washouts more regularly, you know, we need to find ways to quantify that. We need to find the ways that make sense from an analytical framework and develop technical information that guides more and better effective decisions. And this information currently is a little bit limited, so there's definitely a research need associated with that as well. Like, how do we get to more effective decisions? And then there's also the kind of the procedural framework, which kind of is best summarized through this information that's kind of included in the HEC 17 guidance that was issued by Federal Highway Administration, which says, okay, we as transportation professionals, we need to think obviously about designs and the potential for kind of changing flows or changing precipitation patterns. But really, the other thing that we need to take on is we need to recognize that you know, if those values are exceeded, what happens? You know, if the values are exceeded and the road is overtopped and can be fixed pretty quickly, that's one condition. But if the asset is overtopped and there are significant impacts or concerns, then we do need to be taking a different approach to better, more effective decision making. So that part in particular has to certainly flow through it. And there's many examples, obviously, in the south, the southern ITE region of impacts throughout the region of flooding or coastal flooding, or things that are kind of outside of your normal transportation system asset management, like levee failure, that kind of occurred in North Carolina and really had made some damage to the transportation system that would normally be unanticipated if you're only looking at things like stream flow. So definitely a lot to kind of think about and find ways to make better decisions. And as I said, really recognize the intrinsic value of transportation systems and assets as an important part of community viability. Okay, so that kind of brings me to the end of my presentation. So thank you very much for your time today, and I'll turn it back over to Tony, and maybe we can walk through some Q&A.
Thanks, Mike. I appreciate it. I'm looking at the Q&A in the chat right now, and I'm not seeing anything. So if you guys do have any questions for any of the panelists, please go ahead and enter them now. And we'll go ahead and get those answered. And if you don't have any, that's also great. That just means everybody did a really good job of explaining everything really well. So I am not seeing anything yet. So with that, I think we may give everyone an extended break. Thanks again to everyone for attending this, and thanks again to our great panelists for a great session. And the next session coming up after this, we have this 15-minute break, which will extend to about 25, and then we have the Todd Duck Memorial Make It Funner event. That will consist of 3 different virtual sessions. There's a Jeopardy session, a $100,000 pyramid session, and an escape room session. I've never done an escape room virtually. I don't know if I've ever done one in live other than, hide and seek with my kids. So not sure how that's going to go, but there's in the very back of your program on the last page, there's 3 different links to join either of those virtual meetings, and a good chance to go have a good time in the middle of your Wednesday before lunch. With that, I think we are wrapped up. So thank you again, everyone, and have a great day.